Good morning and welcome to today's class. Well, if we recollect what we did in the previous class, I think we had discussed and finished alternating current. Do we all remember this? Alternating current? Have you solved the exercise for that? Alternating current? Anyone has done this? Yes or no? Can I have some raise hand that we have done this?
Yes, sir.
Yes, sir. Okay. Since alternating current is gone, now we move on to the next thing. And the next thing is thermodynamics. And we are going to start thermodynamics with this topic known as KTG. Any idea what is KTG? What is KTG? Don't know it? Kinetic theory of gases. Do we know this? It's a theory that tells us the behavior of a gas. Why does gas exert pressure? What is the contribution of kinetic energy of the molecules? What happens if you increase the temperature of the gas? What is the internal energy of the gas? All these things are basically explained by this concept which is known as KTG. Have you heard this thing before?
Yes, sir.
Yes, sir. So we'll quickly go into it and understand the important points. Most of the question in this particular topic would be of knowledge or theory based, but this will also cover something known as ideal gas law. Do you know this ideal gas law?
Yes, sir.
So it will also cover questions from this ideal gas law. So there could be numericals based on this. So it would be a mixture of questions which are based on theory and numericals as well. Theoretical questions are more likely to come. So let us move on and see some important aspects. And again, we'll start from those points which I think are important. And I'll try to cover as much as possible. So we'll start. Did you get the sheet that I have sent you?
Yes, sir.
Okay, so in this case, we are going to rely on the sheet because this thing covers basically everything that we are supposed to know. If there is something extra, I will ask you to note it down. Now, what we are going to study is simple things here. We all know that matter exists in three states: solid, liquid, and gas. Anyone knows this? Gases have a large number of molecules. Properties of gas is very different from solid, liquid. Solid is different to liquid. Liquid is different to a gas. In case of gas, thermal expansion is very large. What do you mean by thermal expansion? If you heat something up, it increases its volume. That is thermal expansion. You might have seen water boiling or your milk boiling in a container. It comes out. We'll also see that thermal expansion in coming classes. So, what are the characteristics? You all know this. You don't have to note this down. You just read it. Characteristic size and shape. Solid have certain size and shape. Liquid uncertain. Gas uncertain. Intermolecular distance between two molecules. Solid, it is very small. Molecules are very closely packed. Liquid, small. Gas is very large. Even if you have a very small amount of gas, you put the small amount of gas in this room, the gas will distribute throughout the room. That means the distance between two molecules becomes very large. Remember this, it is a very important term. Intermolecular forces between the molecules, they are closer, so the forces are very strong. Here the forces are very weak. Specific heat. What is this term? Specific heat. This is the amount of heat required to raise the temperature of a body by 1 degree Celsius. We'll also come into that. specific heat is infinite. Gases have different specific heat depending on the process. We have specific heat at constant pressure, constant volume. For any process, the gases have different type of specific heat, but for solid and liquid, the specific heat is constant. For example, the specific heat of water is 1 calorie per gram. 1 gram of water for 1 degree rise in temperature requires 1 calorie of heat. If we talk about ice, it is 0.5 calorie per gram per degree Celsius. You all know this, yes or no?
Yes, sir.
You all know this?
Yes, sir.
We all know this, yes or no?
Yes, sir.
Density is very small. Expansion, as you can see, everyone understands this. Gases will expand maximum. Liquids, solid will expand minimum. Now, what you got to do is remember these small things, and a question based on these things can definitely come in the examination hall. In the exam, remember this: intermolecular forces, the order. Solid have the most intermolecular forces, and liquid, real gas and ideal gas. I hope you know the difference between a real gas and an ideal gas. The equation PV is equal to nRT is an ideal gas equation. We assume that the gas is ideal, but gases are not ideal. The gases that we see in day-to-day life, they are real gases. The intermolecular forces are in this ratio. Are you noting it down?
Yes, sir.
Potential energy. Potential energy is the energy that comes in a substance, gas, solid or liquid, because of the position of the molecules or atoms inside that body. Potential energy, the maximum potential energy is for an ideal gas and the minimum potential energy is for a solid. You have to remember these orders because a question will come based on this order. It is simply your understanding and knowledge and your remembrance that will help you. I hope you are noting it down. I don't see everyone noting it down. I see some people relaxing as they are sitting in a garden. Remember, this is not garden, this is your class, and if you can't sit properly in a class, that means there is something wrong with your attitude and you must immediately correct it. Okay, have you noted this down, everyone?
Yes, sir.
Okay, move on to the next thing. At a given temperature, remember I told you the effect of temperature. Effect of temperature at a given temperature for any solid, liquid, real gas or ideal gas, the internal kinetic energy at a given temperature, the temperature is constant, the kinetic energy of its molecules will remain same for all types of material. Internal potential energy, internal potential energy and internal energy, they are two different terms. This internal energy basically consists of internal potential energy as well as internal kinetic energy. Do we understand this? The total internal energy of a gas, it can be divided into two things: internal potential energy and internal kinetic energy. Do we understand this? Internal kinetic energy is same for all the molecules, for all the gases at a given temperature. But if we talk about internal potential energy, it is maximum for ideal gas and minimum for solid. And the maximum potential energy is zero. Potential energy cannot be positive. You must remember that. So the maximum positive value is zero. And it is minimum for solids whose potential energy is taken as negative. Now, when you add these two, internal kinetic energy and internal potential energy, you will have the internal energy of the gas. Internal energy of a gas is maximum for an ideal gas. That is the gases that we are going to deal, and it is minimum for solid. We are not going to deal with solids in this chapter. Have you noted this down? Are you noting it down, baby? Everyone, bacha, are you noting it down? Not getting any response from your side. Are you noting it down? You have to note this thing down. Are you noting it down? Mic is not working. Okay, chalo. We'll move ahead into equation of ideal gas, and there are different ways in this ideal gas equation is written. What are the different ways in which this ideal gas equation can be written? You'll have to remember some ways in which this ideal gas equation can be written. And the first way that you should remember is PV is equal to nRT. Do we remember this way? P standing for pressure, V standing for volume, mu or N standing for the number of moles. I will write this mu as capital N. Capital N. Wherever I write capital N stands for number of moles. Will you remember this? Will you remember this? I don't think you are getting my voice, or maybe the mic is not working. Capital N stands for the number of moles. Small n, whenever I use, there will be points where we'll be using small n. Now the notation in the sheet and notation that I'm going to use are not same. So capital N, the notation that I'm using is for number of moles. Small n is for number of molecules or number of atoms. Will you remember this? This is the notation that we are going to use. Is everyone in the class and noting down things? Raise your hands if you are there in the class and noting down. Everyone. Okay. So the first equation is PV is equal to capital NRT. The second equation that I want you to remember is PV is equal to small n KT. Small n KT. This is how you will remember the equation. Now, the small n is the number of molecules. What is this K? Do you know this? Do you know what is this K? This K is known as the Boltzmann constant. I hope you have heard about Boltzmann constant. Yes or no? Yes, good. Now remember one more thing that you must understand. Wherever you have this number of molecules n, in whatever equation you will get this number of molecules n, that equation will also have R, the universal gas constant, coming in that equation. So basically, whenever R comes, number of moles or capital N will come. As you can see in this equation, you see R and you see N. R and N, universal gas constant and number of moles, they are closely related to each other in the sense that whenever you see N, the corresponding quantity will be R, the number of moles. Remember this. Do not forget this. N and R will come together. Now, if I take the other side of the spectrum, the blue side of the spectrum, wherever you see small n standing for the number of molecules, you will see K, which is the Boltzmann constant, coming there. So small n will be related, small n would be related to K. Small n would be related to K, and capital N would be related to R. Remember this? I hope you have understood this. Okay? I'll give you a minute to note down the equation that are there. If you have any doubts, please ask. And please write. See, please note down these things, because if you don't note them down, beta, you will forget them very soon. Now remember, the name of this chapter is Kinetic Theory of Gases. So most of the things that we are going to study in this chapter are theory, and therefore you will have to remember a lot of things, and question will be coming based on your remembrance, whatever you remember. Am I clear? It's all about remembering the things. If you remember things, you will be able to do a lot of questions. Whatever we are doing, remember they are questions, because they will come as questions in the examination hall. For example, this one. This is also a question. Remember, ideal gas concept. These are points of ideal gas and kinetic theory of gases, and you will remember the same points, and these points will come at question. The volume of the gas molecules is negligible as compared to the volume of the container. Remember all these points. What do you mean by this? Let me try to explain. This you see in my hand is a small piece of grain, right? Now this small piece of grain can be considered as, right now, as a atom of gas or molecule of a gas. As you can see, the molecule or atom of gas, this one, has a very small volume. Now I take one more grain which is here. So I have two grains in my hand. This is one molecule or one atom. This is the other molecule or other atom. Now, as you can see, they have a very small volume. You can hardly see it. Even this is very big. This will have around millions and billions of atoms inside it. I'm just giving an example. So this is, let us say, the size of a molecule of a gas. This is another molecule. Now, they are separated by a very large distance. This is the distance between the two molecules. That is the first point. The size of the molecule is very small. That means the volume of the molecule itself is very small, but they will occupy a very large volume of the container because the distances is very large. Do we understand this? Do we understand point number one? That is point number one. The size of the molecule or the volume of the molecule is very small, but the volume of the container or the volume that they occupy or volume of the gas, you can call it volume of the gas. Volume of the gas molecule is very small, but the volume of the gas or the volume of the container or the volume that these gas molecules occupy is very large. Volume of the gas is ultimately becoming equal to the volume of the container, because volume of the gas molecules is very small. There is no intermolecular forces between the gas molecules. There is no intermolecular forces. So when these molecules are there, they do not exert forces on each other. Remember, we are talking about ideal gases. This does not happen in practice. Therefore, ideal gases are only ideal. They only exist in theory. They do not exist in real. These are the 2 points. There will be more points coming up. Please note them down. Question will be based on this. I will give you a minute to win it. Note it down. Have you noted it down, everyone? Can I have some raise hand that we note it down? Okay. Please remember these points. Here comes the next one. Special point for ideal gases: a gas which follows the ideal gas equation at all temperatures is known as ideal gas. Remember, not all gases are ideal. In fact, no gas is ideal. But most of the gases at very low temperature, pressure, they behave as ideal gas. Will you remember this? At very low temperatures and pressures, though none of the gases are ideal, at low temperatures and pressure, they behave in an ideal way. Remember this, you will have to understand this. Now, another thing about ideal gases is they only have translational motion and kinetic energy is known as translational kinetic energy. They can also have rotational motion. So they only have translational or rotational kinetic energies. Potential energy. Remember, potential energy of an ideal gas is zero. Potential energy of an ideal gas is zero. So internal energy of an ideal gas is perfectly translational energy. It is directly proportional to absolute temperature. So internal energy depends only on temperature. If I say internal energy of a gas, it consists of two components, kinetic energy and potential energy. But potential energy for an ideal gas is taken as zero. So therefore, the complete energy of the gas, complete internal energy of the gas is translational or kinetic energy. It could be translational, it could be rotational as well. It is simply kinetic energy. I'll just take out the term translational from here. Ideal gas only has kinetic energy, does not have potential energy. That is the summary of this line. Please note it down. I hope everybody noted it down. I'll give you a minute.
Completed, sir.
Well done, sir. Then coming to the next point. Again, all the questions are based on this, and these are the next points. Specific heat of a gas. Remember, there can be an infinite number of specific heat. Constant volume, constant pressure, constant temperature, adiabatic process, polytropic process. There can be infinite number of processes. There can be infinite number of specific heats of gas. But remember, for any given process, it is a constant quantity and it does not change with temperature. Remember this. And these are the two graphs. Remember these graphs. For an ideal gas, specific heat remains constant. For a real gas, the specific heat is changing. Please remember these graphs. All real gases behave as ideal gas at high temperature and low pressure. I've already told you that. Volume expansion and pressure expansion is same for an ideal gas. Remember that. All these questions have come in the exam. Gas molecules have point mass and negligible volume and velocity is very high. All these are important points. Question will come based on this. I have seen numerous questions. In fact, more than 90-95% questions are based on these concepts, and we will see that when you solve the exercise. Please remember them. Please note them down. I'll give you a minute. I hope everyone is writing. Is everyone present in the class? I see one boy less, and I don't see Pooja and Kajal. Where are they?
Kajal went to home, sir.
Kajal is
Went to home.
home.
Yes, sir.
Why? What happened? Kajal, someone was raising hand. What was Kajal or Pooja?
No problem, sir.
Pooja, na?
Yes, sir. Pooja is present.
And I think one of the boys is also missing. 4 boys were there, right? Who is missing? Missing person.
Dono absent, sir.
Yes?
Dono absent.
Okay. चलो चलो फटाफट लिखो लिखो फास्ट
Done, sir.
डन सर then sir this thing sir fatafat you'll have to note it down. If you can't note it down, you mark it, but remember, if you mark it, you will never read it, you will never remember it, and you will miss the entire point, because these questions have come. Assumptions of kinetic theory of gases, they will give you as a statement, and then they will give you 4 choices. Mark the correct one. All the molecules of a gas are identical. They are spherical and they are identical, and their shape, mass for one type of gas molecule is same. The molecules of different gases are different. Gas molecules behave as rigid, elastic, and smooth spheres. They are spherical in shape. The molecules collide with the walls of the container. Since they collide with the walls of the container, and that is why the gas exerts pressure. Do we understand this?
Yes, sir.
All these collisions are perfectly elastic. Remember this. There is no loss of kinetic energy in these collisions. You will have to remember each and every word. The molecules of a gas are in a state of continuous motion. They are moving randomly in all directions. They move with all possible velocities in all possible directions. They remain and they obey Newton's laws of motion. Mean momentum is zero because they are moving randomly. Mean velocity is also zero. So average velocity is zero. Average momentum is also zero, but average velocity ka square is not zero. And if I take the root of this average velocity ka square, I will get something known as RMS. Do we remember RMS? Root, mean, square. You first square something, then you find the mean, and then you take the square root. RMS value of current. Do we remember this?
Yes, sir.
That is the same thing that is coming here, and that is the reason that I have taken KTG just after AC, so that you can understand this mean free path. The average distance traveled by a molecule between two collision. Molecules are constantly moving, they are colliding between two collision. Whatever distance it moves is known as mean free path. I'll give you a minute to note it down. Have you noted it down, bacha? Then comes the next set. These may not be so important, but you will have to remember this. The time during which the collision takes place is very small compared to the time between the collision. For example, if time between the collision is 1 second, time for collision will be in micro and nano and picoseconds. Whenever a gas is taken into a vessel, it is uniformly distributed. It doesn't happen that one side has more density and the other side has less density. Root mean velocity. If I take the square and then I take the mean, this is known as root mean velocity. And if I take the square root, this becomes RMS velocity. Do we understand this? Do we understand the value of RMS? We take the velocity, we square it, we take the mean, and then we find the root. So first we square, then we take the average, and then we take the root. If you don't take the root, it becomes mean square velocity. If you take the root, it becomes root mean square velocity. Do we understand this?
Yes, sir.
You can mark these points in your sheet. You can mark these points in your sheet, and now we are going to come to a very critical aspect. Many questions have come here. Shall we move ahead? And you will have to note this down, because most of the questions that come in thermodynamics, KTG or whatever, they are based on graphs. Shall we move ahead? Sorry. Let me know when you are done so that you can move ahead.
Done, sir.
Okay, then we come to the various gas laws. The first law is known as Boyle's law. At constant temperature and same mass of the gas. Remember, whenever we are talking about these gas laws, N, number of moles, or small n, number of molecules, or capital M, the mass of the gas is constant. Do we understand this? In all these laws, these three things are constant. Then pressure of the gas is inversely proportional to its volume, or volume of the gas is inversely proportional to its pressure. These are the two graphs. Between P and V, the graph is like this. Between P and 1 by V, the graph is like this. This is known as Boyle's law. We all know this Boyle's law, yes or no? You will write this Boyle's law and you will draw these two graphs. I'll give you a minute. Please note it down, bacha. Jaldi, jaldi. We are not going to do it again. This is the last time that we are going to do it. Don't fight in the class. Your time is running out. Do it fast.
Saru.
Okay, this was Boyle's law. The next one is Charles' law. We all know this. If the pressure and obviously the mass of the gas is kept constant, volume of the gas is directly proportional to its temperature. V1 by T1 is equal to V2 by T2. We can also write it in this fashion. Vt is equal to V naught into 1 plus alpha T. Alpha is known as the volume expansion coefficient, and that is equal to 1 by 273. I just gave you that data. Yes or no? This is the graph of volume versus temperature in Kelvin. The graph starts like this. This is the graph in degrees Celsius. Do we understand the difference between the two graphs here? Graph number 1 and graph number 2. Yes or no? Graph number 2 is on Kelvin scale. Graph number 1 is on degree Celsius scale. Do we understand this? Okay, raise your hands. You understand this? Okay, I'm going to show the graph on the bigger screen. So you can draw the graph and then you can write Charles' law. Remember, the slope of this graph is V naught into alpha, where V naught is the volume at 0 degrees Celsius. I hope everyone is paying attention. I see some boys talking to each other. Don't talk, beta. You will get a lot of time to talk in the hostel also. Please pay attention here in the class. If you don't pay attention in the class, you will face a lot of trouble in the examination hall. I understand that. I guess that you are not here to talk, but to study. So please concentrate on studying and not talking. Your parents have spent a lot of money in sending you here, and I hope you understand how money is earned. Because when you get out of your MBBS college, you will be getting a job of 10,000 or 12,000 rupees in a government hospital. And that too, when you get selected in NEET and you get a government college, 10 to 12,000 is the amount that you get. And at that point in time, 5 years from now, it will be a very small amount to live your life. So please value money. Have you drawn this graph?
Yes, sir.
Well done, sir. Then you write the Charles law fatafat and do not indulge in extracurricular activities in the class. I would be asking the office people to keep an eye on whosoever is coming in and coming out of the class. There is no discipline at all. Have you done this Charles law? Yes or no?
Yes, sir.
Okay. Then this is the Gay-Lussac law, and I hope you can see it on a screen. Mass of the gas is constant, volume of the gas is constant, pressure is directly proportional to temperature. P1 by T1 is equal to P2 by T2. You can write pressure at temperature T is P naught into 1 plus beta into T. Beta is the pressure coefficient expansion. Again, it is same as volume coefficient expansion 1 by 273. And you can see the graph. Both the graph of volume and temperature are looking same. As you can see here, both the graphs are exactly same. The slope here is P naught into beta. That is the only difference. And the value of P naught is pressure at 0 degrees Celsius. This is the graph on the Kelvin scale. This is the graph on the degree Celsius scale. Everything is in your notes. You can see it clearly in your notes. Now is the time that you note them down with your own little hands, because that is how you will learn. And this is Gay-Lussac law. I'll give you a minute to win it. Have you noted down, bacha? Raise your hand if you noted it down. Chalo. Then comes the next two laws, Avogadro law and Dalton's law. At same temperature and pressure, equal volume of all gases contains Avogadro number of molecules or atoms. You all know this. Dalton's law, according to this law, the pressure exerted by a mixture of several gases is equal to the sum of pressure exerted by each of the gas. I hope you know all the two laws. The next two laws, please note them down in your notebook. I'll give you a minute. Avogadro law, Dalton's law of partial pressure. Note it down. 1 minute. Have you noted down? Actually, don't think the mic is working. Raise your hands. You noted this down? Okay, well done. Then Graham's law of diffusion. Remember, question have come directly on this. The rate of diffusion at the same temperature and pressure, the rate of diffusion is inversely proportional to the square root of density. Square root of density. VRMS is also somehow looked to density, but we will see that it does not depend on density, but just for the sake of argument, therefore RMS velocity and the rate of diffusion are directly linked to each other. This is the most important point that you should remember. So if you know the ratio of RMS velocity, you can say the rate of diffusion. If you know the rate of diffusion, you can talk about the RMS velocity. Please note it down. I'll give you a minute to note it.
Done, sir.
Done, sir. Then well done, sir. Then this is the problem that comes for you, sir. The pressure of 1 gram molecule, you basically, I hope you understand 1 gram molecule means 1 mole. The pressure of 1 mole of hydrogen and argon in a given container will be as follows. Who will be more? Who will be less? Answer, bacha. Who is more? Who is less? Same temperature, same pressure, no. Same molecule, same number of molecules, same number of moles. Yes. I can't hear you. What is the answer? Answer is 3. Answer is 3. Answer is 3. We move on to the next one. And the next one is not this one. This one was the previous one. We move on to the next one. I hope you understand this. PV is equal to nRT. volume is same, container is same, temperature is same, number of moles is same, everything is same. That is the next question. Example number 4. Please give me the answer for this one. A sample of oxygen with volume of 500 cc is a pressure of 2 atmosphere. Is compressed to a volume of 400 cc. What pressure is needed? Temperature is kept constant. I'll be waiting for your answers. Example number 4 in your sheet. Example number 4 in your sheet. Example number 4 in your sheet. Do it fatafat. I'll give you a minute. Anyone with an answer? 500 cc of oxygen has a pressure of 2 atmosphere. What is the pressure of 400 cc of oxygen? And the result is very simple. Yes or no? We all can do this. Please raise your hands. I can't see any raise hand from girls. Are they in the class or sleeping? Boys are there. Girls are not there. Okay, so how do you do this? It's very simple. Temperature is constant, so you can apply the first law. What is the first law? The first law is your Boyle's law. Yes or no? P1 V1 equal to P2 V2. First pressure is known. First volume is known. Second volume is known. You can find out the second pressure. I hope all of you understand this. First question. Now let us move on to the next one. We don't have time, so we'll do it quickly. And this is the next one in line, which is example number 5, which comes on your screen right now. 1500 ml of a gas at the room temperature of 23 degrees Celsius. Remember, whenever you apply gas law, temperature has to be in Kelvin scale, not on the degree Celsius scale. Mark this as an important point. Temperature should be on the Kelvin scale. Is inhaled by a person whose body temperature is 37 degrees Celsius. If the pressure and the mass stay constant, what will be the volume of gas in the lungs of the person? Wow. A very good question for all you kids. Your time starts now. You will get a minute, 2 minutes. Have you all got the answer? Please raise your hands. It may involve some calculation, but remember, when the options come to you in the examination hall, they might not be in the form of decimal, they might be in the form of fractions. Remember, Pressure and mass of the gas are constant, so we can apply V1 by T1 is equal to V2 by T2. We know the first volume as 1500 ml. You know the first temperature as 23 degrees Celsius. 23 degrees Celsius has to be converted into Kelvin. That becomes 296. I hope you know how to do this. The next temperature is 37 degrees Celsius. That has to be converted into Kelvin. That becomes 310 degree Kelvin. 310 Kelvin. That is my T2. That is my T2. I hope you understand T1 and T2. This is my T1. Yeah, sorry. This is my T2. And the yellow gentleman is my T1. I hope you understand this. Yes or no? V1 by T1 equal to V2 by T2. And we have our answers coming here. 1500 into 310 by 296. Then I have some raise hand from everyone that we have understood this. Yes, sir. Okay, sir. Then that takes me to the next question, sir. We have done one question of pressure and volume. We have done one question of pressure. Sorry, volume and temperature. Now comes the third one that obviously consists of pressure and temperature. Here is the question on your screen. A sample of O2 is at a pressure of 1 atmosphere when the volume is 100 ml and the temperature is 27 degrees Celsius. What will be the temperature of the gas if the pressure becomes 2 atmosphere and the volume remains 100 ml? You have a minute to win it. Have you done this, bacha? Have you got the answer? Initial pressure is given, initial temperature is given, final pressure is given. You have to find out the final temperature. Volume of the gas is remaining constant. Do you have the answers? Can I have the answers, please? Are you still trying? I'll give you one more minute. Everyone has done this? Yes. So what you got to do is do simple stuff. Simple stuff. P1 by T1 is equal to P2 by T2. So T2 becomes P1, P2 by P1 into T1. T1 first temperature is 27 degrees Celsius converted into Kelvin, 300 Kelvin. Second temperature will get, it will be 600 Kelvin in degrees Celsius. It will be 327 degrees Celsius. I hope all of you got this. I hope all of you got this. Yes or no? Please, can I have some raise hands from everyone in the class so that I understand that everyone is there? Yes, 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 yes. Now, As expected, we'll see what type of questions do come, and then again, I must tell you that most of the questions are based on theory and your knowledge. And this is the first one that comes online. First one that comes online. Yes, the pressure exerted by gas on the walls of the container because. Tell me. Are? Question number 1. No answers. Okay, you can't speak right now. I'll give you a chance to tell me the answer in terms of this. 1, 2, 3. Which one? 4. A, B, C, D. What? Why does the gas exert pressure? You don't know? It exerts pressure because of. Oops. What has happened here? What has happened here? Something wrong has gone. It exerts pressure because it is colliding. The molecules of the gas are colliding. Yes or no? We understand this? Okay. As you can see, most of the questions are based on your knowledge and your understanding, and these questions can very well get repeated. This is the next one that comes online. The temperature below which a gas should be cooled before it can be liquefied by the pressure. By pressure only is termed as, again, a thing from chemistry, probably. But you must know it. It can come in physics as well. This topic, kinetic theory of gases, is common to both physics and chemistry. So that is why I have done this. The entire topic of thermodynamics is there in physics as well as in chemistry. Some subtle differences which I'll let you know. What is the answer for this one? 1, 2, 3, A, B, C, D. What? The gas, the temperature at which it is liquefied, it is not 2, it is not freezing point, Gade. It is a critical point. If you don't know this, you are going to get -5. Please remember this, and that is the entire reason that this exercise is being done. We got this? Critical point. Everyone? We got this? Comes next one. Fatapat, give me the answer. The equation for an ideal gas P is equal to mu RT, where V represents the volume of what? 1 gram of gas, any mass of the gas, mu mole of the gas, or 1 liter of the gas. This is how they confuse you. This is how they confuse you. This is how they confuse you. What is V? Here, everyone must look into their sheets. Everything is from your sheets. Question number 3. The equation for an ideal gas P is equal to mu RT. V represents the volume of what? A, B, C, D. 1, 2, 3, 4. If you are taking so much time to solve this, well, you will not be able to score much marks. A, B, C, D. What is the answer? And the answer is 3. It will stand for volume of mu moles of gas, because it has to be the volume of mu moles of the gas. If this question was put in this fashion, PV is equal to NKT, then the answer will be N number of molecules. Do we understand this? Yes, good one. That takes us to the next one. And again, as I've told you, everything is based on theory. Question number 4, I will not read it out, or I'll read it out. The temperature of a gas is a measure of A, B, C, D. A, B, C, D. A, B, C, D. The average, the temperature of a gas is an indication of what? And the answer is 1. Temperature of the gas, internal energy of the gas is 0. We all understand this. Let us move on to the next point. Next question. Question number 5. Here it comes. If the pressure in a closed vessel is reduced by drawing out some gas, the mean free path, mean free path We might not have studied about mean free path, so I will just give it a pass. I will just give it a pass. The answer is increase. How does it increase? I will let you know. Probably by the end of the next class, you might be able to make more sense of it. Right now, I will give this a miss and I move on to the next one. And the next one is here. Chalo, jaldi, give me the answer for this one. For Boyle's law to hold, the gas must be dung 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 dung. You should not take so much to solve this, else you are doomed. Yes, what is the answer? Option A, option B, option C, option D. You're saying option D. Shame on you. Shame, 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 shame. It has to be constant mass, bacha, constant temperature, and it must be perfect. It is so difficult to understand. It cannot be so difficult to understand. If you have problems in understanding Boyle's law, well, I don't have words to say, so I'll not say anything. I'll move on to the next question. Question number 16. Question number 16. Absolute zero temperature. What will happen? All liquids will convert into solid, all gas will convert into solid, all matter will remain in the solid state, all matter will remain in the liquid state. Number D, the kinetic energy of the gas molecules becomes zero. What is the answer? Oh, chalo, 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 chalo. We get +4 here at least. Good, good, good. Not bad going. Not bad, not bad. This one comes here, 18, question number 18, question number 18, 18, 18, 18, 18. Let's see who gives me this. Let's see who gives me this. Equal molar amount, same mole, equal molar amount of H2 and helium, molecular mass 2 and 4, are filled at same temperature in two containers of equal volume. H2 gas has a pressure of 4 atmosphere. What is the pressure of the helium gas? What is the answer? What is the answer for this one? And the answer is, you can't take so much of time to do this, bacha. Else you are doomed. Answer is 2. Answer is 2. Equal volume of all gas and whatever. That is the answer. You must remember that PV is equal to nRT. Number of moles is same. Temperature is same. Pressure and volume have to be same. I hope we are making sense of what we have done. We cannot do all the questions. You will have to do the rest of the question on your own. Here comes the next one that I can do here. At 0 Kelvin, which of the following properties of an ideal gas will be non-zero? Most of them are zero. Which one is non-zero? Which one is non-zero? Which one is non-zero? Which one is non-zero? The options are kinetic energy, potential. Potential spelling is wrong. It may be potential, it may be rotational. Anyways, potential energy, vibration energy, we don't know about these energies. Density, which of the properties of the gas will be non-zero? And the answer is question number 25. Do fatafat. I don't have the time of the entire universe. Last night I was watching a movie. The name of the movie was Tenet. It's a very good science fiction movie directed by Christopher Nolan, one of my favorite directors. And in that, they have a machine through which, if you go, time moves reverse. Time does not move reverse. You move reverse in time. And fascinating things happen. Yes. 0 Kelvin. And the answer is 4 density. Answer is 4 density will remain non-zero. And I move on to the next question. Question number 20, 20, 20, 26 on your sheet. Relation P is equal to RT is given for the following condition for real gas. Real gas. Real gas. High temperature, high density, low temperature, low density, high temperature, low density, low temperature, high density. What is the answer? Again, everything is based on your Your what? High temperature and low density. Low density. That is correct. High temperature and low pressure. Remember, there is one more. Remember, there is one more form of the ideal gas. P is equal to rho RT by M. Have you seen this form of ideal gas equation? Yes or no? No, don't worry, then you have seen it now. So there are three forms of ideal gas equation that you know. PV is equal to capital nRT, PV is equal to small n KT, and P is equal to rho RT by M. Pressure is directly proportional to density in that case. If temperature and molecular mass of the gas is constant, therefore low density correspond to low pressure, and that is why the answer is 26. We get this or no? Are? Do we get this or no? Yes, and I'll do one last question, and after that I'll leave the entire thing for you to do. You cannot do all the questions because we have not covered the entire chapter. You can only do the question of which we have covered, and this is the last one for today's class. Two gas of equal molar mass. Equal molar mass means the molecular mass is equal, are in thermal equilibrium. Thermal equilibrium means same temperature. PA, PB, VA, VB are their respective pressure and volume. Which of the following relation is true? Molar mass is equal. Thermal equilibrium, temperature is same. What is the answer? And the answer is? They have same molar mass. If molecular mass are same, basically it's the same gas. They are in thermal equilibrium, same gas, same temperature. And the answer is D. Do we understand this? Yes or no? We understand this? Yes. Let me see if I have time for one more. I may have time for one more. And this is that more. Let us see if we can make it more. Plus 4 or minus 5. Let's see your answer. Plus 4 or minus 5. If you do any question of KTG wrong, it is minus 5. It is not minus 1. Remember that. You cannot get a simpler question than this, bacha. Two balloons are filled, one with pure helium and other by pure air. Air is always pure. In Delhi, it is not pure. If the pressure and temperature of these balloons are same, then the number of molecules per unit volume, A, B, C, D. What is the answer? They'll ask you the same thing in different ways. If you don't understand them, you are gone. Minus 5 would be your score. What is the answer for this one? Question number 34 is what we are looking at. Answer is not 1, more in helium. Answer is not 3, more in air. You are guessing. Equal volume of all gases are all it's a similar thing, and this and equal volume, equal mass, equal molecular weight. You have to think about this. I hope you have understood this. You have understood this, yes or no? PV is equal to nRT. That is the entire thing. Nothing else. Pressure and temperature are same. Okay, so at this point in time, I will take your leave. Tomorrow, be on time in the class. I don't like anyone coming late. I'm never late for anything that I do. Even if I am late by a minute, I make sure that I apologize for that, and I let the other person know that I'll be late by a minute. If you can't value time, time will not value you, and if time kicks you, you are gone. Value time. Time is not going to come back. We are not in the movie Tenant that you can go through a turnstile and you can move backwards in time. You just can't do it. It's a science fiction story. Till then, till tomorrow, I'll see you. Be on time. We'll start the class on time. Take care. Have a nice day. May God bless you all.